equation, there are certain things we need. The first thing we need are like bases. So remember, if the base is greater than 0, and also the base does not equal 1, if bases are equal, then exponents, bases are equal in an equation, in an equation, then exponents will be equal. An example of this would be if I had b to the x is equal to b to the y, because they have the same base, right? And this equation is saying the left side has to equal the right side. Can't we conclude that x then would have to equal y? Okay, and I put a couple of restrictions here. I said if b is greater than 0, well, we've already said in exponential equations, we want b to be greater than 0 because if it ends up in the negative world, right, we could end up in imaginary numbers. So in that scenario, that came from before. But now I'm also saying also if b does not equal 1. And that makes perfect sense because if I have a base of 1, anything it's raised to would still be 1. So it wouldn't necessarily be true that x is equal to y, right? So those are sort of the restrictions here. Now also, let's say I have b to the x is equal to a to the x. In this scenario, I have an equation which is telling me the left side has to equal the right side. But in this scenario, the bases aren't equal. What are equal? The exponents. But if the exponents are equal and it's an equation, doesn't that mean then the bases would have to then be equal also? So therefore, in this scenario, A would equal B as long as if x does not equal 0, right? Okay, so now I'm going to say most of the time, so it's not always, but most of the time, it's easier to convert a larger base to a smaller base. With fractions, convert the smaller to the larger. Fractions with a numerator of 1. write as a whole number raised to a negative exponent. And an example of this would be if I have 1 over 2, let's say raised to the x power, it's better to change this to -2 raised to the negative first power raised to the x. So when we have a fraction with a numerator of 1, it's best to change that to a whole number raised to a negative power. How come I'm saying that really is only helpful if the numerator is 1? Why is it only helpful if the numerator is 1? Like, how come if I have, I don't know, 2/3 raised to the x, it's not helpful to make it a negative? Because exactly, because if my numerator is not 1, if say I have 2/3, if I make this a negative exponent, then it's just going to be 3/2 raised to the negative first raised to the x, which is still making me have a fraction. So it's only helpful to change to a negative exponent if that's going to take away the fraction for me. Okay, so now let's do some sample problems. We're going to solve. And the first one is 2 to the x equals 8. We can do this in our head. 2 to what power gives us 8? The third. Do you think it's always going to be something so simple that we can solve in our head? No. So I'm going to start with a simpler problem to show you the process. So when we have an equation where the variable is the exponent, what we want to do is we want to make the bases the same if possible. So it's easier to make a smaller base, a larger base into a smaller base. So you have to ask yourself, is there a way to change 8 into a base of 2 by raising it to some exponent? Yeah, absolutely. I can change 8 to a base of 2 if I have 2 to the third power. So now that we have the same base, it's saying 2 to the x is equal to 2 to the third. Now we can set their exponents equal, and we get x is equal to 3. "25 to the r power is equal to 5. Again, this is we're solving for the exponent. So we try to make them have the same base. And the best way to make them the same base is to change the bigger base into the smaller base, if possible. Can I change 25 into a base of 5? Absolutely. Isn't 25 the same as saying 5 squared, now raised to the r, is equal to 5? Since there's no exponent there, what exponent's really above that 5? 1. When you have a power to a power, what does the rule say to do? Multiply. So isn't this 5 to the 2r equals 5 to the first? Now that we have the same base, we set their exponents equal to each other. So 2r equals 1. Solve for r, so we divide by 2. R is equal to 1/2. Can I change 64 into a base of 16 by raising it to some exponent? No. 16, there's no exponent that I can, or I guess whole number exponent that I could raise 16 to get me to 64. But can I change them both into a base of 4? So I'm going to do that. So I'm going to change 16 into a base of 4. So that becomes 4 to the second raised to the 3x power. 64 becomes 4 to the third raised to the x plus 1 power. Now, do we agree power to a power we multiply? So this is going to be 4 raised to the 6x equals 4. Now, because I'm multiplying a monomial by a binomial, don't I have to distribute in that 3? So this becomes 3x plus 3. So now that our bases are the same, I can set their exponents equal. And I'm going to get x is equal to 1. What do you think I'm going to recommend we do, since both of the bases are fractions with numerators of 1? Since both of these bases are fractions with numerators of 1, what do you think I'm going to recommend we do? Violet? You got it. So this is going to become 2 to the negative first power raised to the 3x power. And this is going to be 4 to the negative first power raised to the x plus 2 power. Now that I was able to make my bases whole numbers, can I change 4 into a base of 2? Is that possible? Yeah, absolutely. So now I'm going to set 4 into a base of 2. So this is going to be 2 to the negative 3x is equal to 2 to the second raised to the negative first raised to the x plus 2. Power to a power we multiply. So this first becomes 2 to the negative 2 raised to the second raised to the negative first is 2 to the negative second. But then I'm going to raise that to the x plus 2 power. I'm going to have to distribute that negative 2 in. So I'm going to have 2 to the negative 3x is equal to 2 raised to the negative second, negative 2x minus 2 power. Oh, not minus 2, minus 4. Now that my bases are the same, I can set my exponents equal. Negative 3x equals negative 2x minus 4. We're going to have negative x equals negative 4, so x will equal positive 4. Okay, I want us to, we're still going to do more problems. What number am I up to? Oops, we still recording? Good. All right, let's number 5. I want us, we're still doing more problems, but I want us to look at how something looks different. Okay, I want to talk about how these problems are different because it does make a difference. In this problem, do we agree that I'm solving for the exponent? Because I'm solving for the exponent is unknown. I have to make sure that the base is positive, right? Because when the exponent is unknown and I have a negative base, that could end up with an imaginary number. Do we agree? Okay, so this was sort of what we were talking about before. When the exponent is unknown, when the exponent is a variable, my base must always be positive. But in a scenario like this, x squared equals 16. I know what the exponent is. Since I know my exponent is squared, is it okay to have a negative base? Yes. So it is absolutely okay to have a negative base in this scenario. Is it okay to have a negative base in this scenario? No. So let's write this down. Because the base is the unknown, and we know the exponent, it is okay to get a negative base as long as it's not an extraneous solution. In this scenario, when the exponent is the unknown, we are not allowed to have a negative base. So if we were to solve this right side, x squared equals 16, do we agree it'd be plus minus 4? X equals plus minus 4. Okay, answers plus minus 4? Absolutely. Okay, so let's say I have x to the 2/3 equals 16. Am I solving for the variable? Am I solving for an exponent? No, I'm solving for the base. So I know my exponent. Is it okay to have a negative base if I know my exponent? Yes. So now I need to solve for x. In order to solve for x, I needed to get it to the first power. Who remembers? We did this when we learned exponential, when we were learning exponents. Who remembers what can I raise x to the 2/3 by to get it to be an exponent of 1? The reciprocal 3/2. But who also remembers if the denominator of what we're raising it to is an even number, what do we have to account for? If the exponent of what we're raising it to, the denominator of that exponent is an even number, for our case, it's always just been 2. Amanda? Good, because if I'm raising it to a fraction and that denominator is 2, isn't that the equivalent of taking the square root, right? Taking it to a half is the same as taking the square root. And when we're solving and we're taking the square root, don't we have to account for plus minus? All right, so now I need to raise this side to the 3/2 power, but I also know I have to include that plus minus because it's like taking the square root of something. Should I put a little star there and write that out for you guys to remind you? So when we are raising an exponent with a denominator of 2, it's like taking the square root, so we include the plus minus. Okay, now we've spoken about this before. We've actually done problems just like this before. I'm now going to tell you to change this 16 into something raised to some power. What power am I going to try to raise it to and why? Ariana? Good. I want to ask myself, can I change 16 into some number raised to the second power so that I can cancel out the twos and not have a fraction? Absolutely. 16 to what number? Sorry, what number raised to the second power is 16? 4. So we have x to the 2/3 raised to the 3/2 is equal to 4 to the second, sorry, plus minus 4 to the second raised to the 3/2. Now 2/3 raised to the 3/2 cancel. The 2 cancels with the 2. So now I'm just going to have x is equal to plus or minus 4 raised to the third power. Who remembers my rule for exponents? What did I always say when you have some number raised to an exponent? 5 or under. 5 or under, we multiply it out. Over 5, we can leave it as exponential. So 5 or under, we multiply it out. Over 5, we leave as exponential. So we're going to have x is equal to plus or minus 64. All right, let's keep going. Okay, so now I'm back to solving for an exponent. When I'm back to solving for an exponent, do we agree our bases have to be positive? All right. This is also 4 to the first power. Can I make 4 into a base of 2? Absolutely. So we're going to have 2 to the absolute value of x plus 2 equals 2 to the second power. Now that my bases are the same, I set my exponent to equal. So I'm going to have the absolute value of x plus 2 is equal to 2. So now we got to think back to algebra 1. When we solve an absolute value equation, don't we take x plus 2 equals 2 and x plus 2 equals negative 2? So we will get x equals 0 or x equals negative 4. In this scenario, is my exponent unknown? No, my exponents are known. So is it okay to have a negative base? Yes. In this scenario, my exponents are known, so it's absolutely okay to have a negative base. So now I have 2 to the 5th power is equal to x plus 3 to the 5th power. Because this is an equation and my exponents are equal, don't my bases then have to be equal also? So now my equation is going to be 2 is equal to x plus 3. Because my exponents were equal in this equation, my bases also have to be equal. So what is x equal? Negative 1. You guys try this one on your own. What do you think I would tell you to do with that 1/8? So besides Ariana, Charlie.
Put it to the negative root. It's the power negative. Break it down.
I would first put it to a negative first, right? So I would have x to the negative third equals 8 to the negative first. Am I able to set these equal to each other right now? No. I have, there's two different ways I could do this, actually. I'm going to show you both ways. The way that would sort of piggyback on what we've always done in the past is I need to get x to be to the power of 1. So what would I need to raise x to get it to be to the power of 1? Not Ariana, somebody else. What do I have to raise x to the negative third power to get it to be negative 1? Lily? Positive 1/3? Negative 1/3, because the negative times a negative, isn't that a positive? So now if I raise this left side to the negative 1/3, I have to raise this right side to the negative 1/3. Do we all agree? So now these cancel. Do I need to account for plus or minus on this right side? I do not need to account for plus or minus because my denominator is an odd number, not an even number. And when we raise a power to a power, don't we multiply? So now I'm going to have x is equal to 8 raised to the 1/3 power. My next step, if we're sticking to how we've always done things in the past, I would say, is there a way to change 8 into some base raised to the third power? Is that possible? Yeah, I can change 8 into 2 to the third power raised to the 1/3. And why did I do that? So the 3's cancel. So we end up with x is equal to 2. So that's the way we would have done it in the past. And to be honest, that's the way I would continue to stick with doing it. Does anybody know, though, another way we could have done it from this point? X to the negative third equals 8 to the negative first. Lily? You got it. We could have a lot quicker changed 8 into 2 to the third power raised to the negative first. So then that would be 2 to the negative third power. And then if our exponents are the same, don't our bases have to be equal in the equation? So that is the quicker way to do it, but not consistent with how we've been doing it in the past. All right, next one. We need to solve for x. Because I know my exponent, is it okay to get a negative base? Absolutely. Because I know my exponent, it's okay to have a negative base. Now, in order for me to solve, I need it to be x to the first power. But before I try to get it to x to the first power, I need to get anything that's with that x that's not raised to that same exponent away. So what number do I need to get away here? What number do I need to move? Ariana? The negative 3. So that negative 3 is being multiplied. I'm going to divide it. So now we'll end up with x to the 2/3 equals positive 4. Now that whatever quantity is the exponent is being raised on is by itself, now I can solve for x. So I have x to the 2/3. What am I going to raise that to get it to cancel? X to the 3/2. Is it important that I pay attention to the denominator that I'm raising it to? Absolutely. It's not the denominator that's originally there. It's the denominator that I'm raising it to. Because the denominator that I'm raising it to is 3/2, that 2 in the denominator, what do I have to account for on the other side? Plus or minus. Because this is essentially like me solving by taking the square root, right? So now I'm going to change that 4 into 2 to the second raised to the 3/2. Why did I change the 4 into 2 to the second? Violet? So not the whole 3/2. Yep, so I could cancel out that denominator. So I'm left with x is equal to plus or minus 2 to the 3rd power. Do I have to multiply this out? Yes, 5 or under we multiply out. So this becomes plus minus 8. Remember when we first started talking about logs, does a log need to be written as an equation? No. A log does not need to be written as an equation, but we could still change it into an exponential equation. So who remembers? How would I change log base 27 of 1/9 into an exponential?
Base 27 to the x equals 1/9.
You got it. 27 to the x power equals 1/9. I'm going to change a couple of things here. The first thing I'm going to change is the 1/9. Does anybody know what I'm going to change the 1/9 to? Am I going to change the 1/9 to? Amanda? You got it. So now I'm just dealing with whole numbers. And now I'm going to change both bases. I'm going to change both bases into a base of what? 3. You got it. So 27 becomes 3 to the 3rd raised to the x. 9 becomes 3 to the 2nd raised to the negative 1st. Power to a power we multiply, so we have 3 raised to the 3x equals 3 raised to the negative 3rd. Because my bases are the same, can I now set my exponents equal? Yep. So we're going to have 3x is equal, oh, sorry, not negative 3rd, negative 2, right? Nobody caught that? Yeah. Is equal to the negative 2nd power. Divide by 3. X is equal to the negative 2/3. Is it okay that my exponent is negative? Is that okay to have a negative exponent? Absolutely. All right, last problem for today, and then we'll go over the homework. What number is this, 12? If f of x is equal to log base 2 of x, find f of root 2. So if f of x is equal to log base 2 of x, find f of root 2. What does this mean, f of root 2? It means go to my equation, log base 2 of x, and wherever I see x, what am I subbing in instead of x? Root 2. So now this is going to be log base 2 of root 2. Anybody confused with how I got this part right here? This is not my answer. This is just my substituting in. Anybody confused with how we got log base 2 of root 2? All right, now we need to change this into an exponential. Somebody change this into an exponential for me. Not Ariana, not Charlie, not Lily. Somebody else. Somebody I haven't, not Amanda. Somebody else. Change log base 2 of root 2. Ira. X squared equals root 2? No, remember it's log base. Our argument is our answer. You got it. Equals exponent. So we're going to have 2 to the x is equal to the square root of 2. Can I write the square root of 2 as an exponent? Yeah, what is the square root of 2 as an exponent? 2 to the half power. So if I have 2 to the x is equal to 2 to the half, do we agree x is equal to a half? Let me just make sure there's no other types of problems I want to show you.